We're going to get started today and we're going to talk about histograms. So we're going to need to be on journal page 26, and you will also need your interactive binder or notebook for a minute. We're going to be on page 10 there. What I want you to do right now, we're going to stop and pause the video a couple times so you can solve some problems, is I want you to look at page 26 and I want you to do question 1, A through D. Go ahead and do that. Pause the video. Go ahead and answer those questions. All right, here are the answers you should have gotten. There are 2 cities that receive over 60 inches. You can see that in green. Between 50 and 60 was 4, and between 40 and 50 was 9. So instead of taking all of these individual numbers, and if you can see there's no mode of the data, okay? So because there's no mode, each of them, if we take them down here to graph them, would be a separate piece of data. So instead we group them. Why might someone be interested in this? Well, maybe they're looking to move. Maybe it's a meteorologist studying weather. Maybe someone with their government looking at the amount of precipitation from year to year. I don't know. Okay, so they ask us to take the information from problem 1 to make a bar graph. So a bar graph has to have a title. So we wrote on page 10 in our interactive binders that a good graph has to have a title and axes labeled. You can see here that we did go ahead, I gave it a title. So precipitation, I abbreviated, but precipitation in major U.S. cities. I put my precipitation down here, so my groups in inches, and then the number of cities here on this side, okay? I took my blue, my 9 right here, and I put it down here. And then I took my 4, put it here, and then my 2 in the last column. Okay, so you can stop, pause this for a minute, and you can go ahead and write down your graph, okay? And then after you do that, you want to look a little closely at it, and we're going to kind of notice how it's a little bit different than a typical bar graph. All right, now that you have your graph written down, let's go ahead to page 10 in our interactive binders. It looks like this, okay? So we had already written down that a good graph has a title and axes labeled with units. We had already worked on dot plots. Now we're going to move to histograms. So histograms, you'll notice it looks just like a bar graph. Okay, see how that has bars here instead of dots? It shows the frequency or the amount of the data in equal intervals, or we call these bins. So instead of telling all the 8-year-olds and the 9-year-olds and the 10-year-olds as 3 separate columns, and then the 11-year-olds and the 12-year-olds and the 13-year-olds is 3 more columns, and the 14, 15, and 16-year-olds is 3 separate columns. Instead, they put them into groups. So go ahead and write those down. It's a bar graph, but it's a special type of bar graph that shows the frequency or the amount of data in equal intervals and bins. So they kind of go ahead and they group things together instead of having each age group separately. All right, on our previous journal page, we were able to practice making one. Now we're actually going to take and look at the data here and see how they took this data and they put it over here into this histogram. Because again, you're going to notice that it looks to me as I'm looking through this list that every single one of the numbers here is different. It's unique. So there again is no mode. So when there's not a mode, we would have to put a single column. We had to put Cheyenne, Washington down here. We had to put Great Falls down here. And we would have 15 cities spread the whole way across the bottom, which, by the way, this is called our x-axis. This is our y-axis. I remember that. Is that the y, the tail of the y goes straight up and down. Okay? So the numbers on the horizontal axis represent snowfall in inches. The vertical axis is my up and down axis. It's the number of cities. Okay, and typically we put the number over here on the left-hand side. So the number of something, 1, 2, 3, 4, 5, and so forth goes up like that. Okay. Which interval, remember, or bin, we just wrote that in our interactive binder, contains the greatest number of data points? So now we don't have a mode over here in this list, But when I come over here to my histogram, we do have a mode. Because the problem, the histograms are nice in that they group the data together, so it makes it a little bit more concise, a little bit easier to summarize. The problem with it is that if this table is not here, so I'm crossing it out, if you pretend you cover that up, we don't know the specific numbers on our histogram, which we're going to talk about, okay? So which interval or bin contains the greatest number of data points? Well, there are actually two of them. Here they are. So we have the 60 to 70 and the 70 to 80. Now, one important thing to note, that this is actually the number 60 up through 7, not up until, but not including 70. So it would be 69.99999 repeating. Once we get to 70, 70 goes in here, up through 79.99999. If I had 80, 80 would go in this next bin. So the answer to this one would be the 60 to 70 and the 70 to 80 bin. There are two answers to that one. Why might it be useful to display the data grouped into bins? Well, remember I told you if we took each of these 15 cities and I put them separately here, that would take me a long time to look through the data. But now that it's in groups, I can see trends, or I can see patterns happening. I don't need to necessarily look at the specific numbers, okay? It also helps me to summarize or get an overall picture, which is helpful. All right, I just talked about this. How would you include a city with an average annual snowfall of 70 inches on the graph? It would go in the 70 to 80 inch bin. Once I get to that number, I always put it in the column to the right. And then if we had a city that only received 55 inches, where would we put it? Could we put it in this first bin here? Nope. We would have to shift all of this over, okay, move all of these columns over, and we would have to put a 50 to 60 bin in here, and then put all my numbers over here to the side. Now you notice I can draw lines straight across here, and I can read each of these bins, right? So if I had a 55 to 60 or 55, I would have to add a bin for my 50 to my 60 range. All right, we're going to do a little stopping and pausing here. I'm going to have you practice some, and then we will go over some of it together. So, oops, let's get that mark off of there. Sorry about that, guys. We are going to take our data and we will put it into bins. Now, I can see that they already have it set up for us, which is super nice. So I'll make things a little bit easier here. So I want to find between the ranges of 35 up through, but not including 40. So if I come up here and look, I don't see anyone. So let's go to the next range, or next bin, which would be 40 up through, but not including 45. Looks to me like I have a 42 and a 43. So that means that there were two presidents that were between the ages of 40 and 45 when they were inaugurated. Let's go to my next bin. 45 up through, but not including 50. So it looks to me like there's 1, 2, 3, 4, 5, 6, 7. So I'm going to take that the whole way up to 7. You see how if I were to follow that across, it would take me to 7. I'm going to follow that down. Okay, let's do one more together, and then I'm going to have you work on it a little on your own. Let's do the next one. 50 up through, not including 55. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I want to come the whole way up here. And I'm going to draw a huge, remember again, these are called bins because I'm putting a whole group of numbers in here. So once I lose this chart over here on the left and I just have this histogram, I don't know the specific numbers in my graph, which is a little bit one of the disadvantages. All right, I'm going to want you to pause this video, and I want you to finish drawing the histogram. All right, ladies and gents, hopefully you were able to do that, and your graph looks just like mine. Again, let's review. This is called a histogram because our numbers are in bins, and all of these bins and these ranges are down here on the bottom. Okay, we have our title, we have our labels. The number of presidents goes along the y-axis, and along the x-axis is our bins. How many presidents, let's look at our questions. How many presidents were at least 60 years old at their inaugurations? So that means I'm going to come here to our 60, and I'm going to draw a line here just to show you that it's not just 1, 2, 3, 4, 5, 6, 7, but these folks here, 8, 9, 10, were also greater than 60. They were actually greater than 65. Which age group has the most presidents in it? And if we look here, I look at my column that has the most in it, and that would be between 50 and up to, but not including, 55 years old. Okay. Now, it would be interesting for us to go up here and look and see. It does look 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 4. It does look like 54 is actually our, 54. And if you look up here, 51, 51, 51, 51. So there's 5 51s and there's also 5 54s. So it looks like the mean of our data, both means, or not means, excuse me, our modes actually fit here under our highest bin. All right, what do you notice about the general trend of the data? So that means, do you notice any patterns? Do you notice anything that you can summarize? If I look at this, I notice that from 40, it starts to go up, 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 up. And these two middle bins here are our highest, where it peaks and then it starts to come back down. We are going to talk in class about how we call this symmetrical, meaning the left side looks very similar to the right side. Okay, so I noticed that many or most of our presidents are between the ages of 50 to 60 are where most of our presidents are. Okay, we have 2 presidential candidates who are much older than that this year. Alrighty, but you can see that the ages of 50 to 60 are most popular. It says the U.S. Constitution, if we look at question 4, states that the president must be at least 35 years old. Why do you think there are not any presidents who were inaugurated between the ages of 35 and 40? It's an interesting question as well, but typically when we think about a candidate for president, we are looking for someone who has a lot of experience, both in our country and in the world. And typically between the ages of 35 and 40, people are still getting that experience. So I think we look more towards older individuals, particularly in this election. Not always necessarily in this election or in all elections, but that is the case in this one. So I think oftentimes it comes down to experience. And as you get older, you have more experiences in life that people use to help them in situations like being a president. So that's our information about histograms. They are just like bar graphs. We need a title. We need to have labels for them, like I circled there in red. We need to make sure our bins are on the bottom, on the x-axis, and the number goes up the side. We want to make sure that our bins are equal. So I can't make one bin. If I grab a color here, it might be hard to see. I can't make one bin between 35 and 45, and the next bin only be between 45 and 50, and then the next bin include like an interval of 15. Do you see how they all count by 5? In our previous histogram back on Or actually our other two that have to do with the precipitation, they counted in groups of 10. So our bins have to be evenly stacked or evenly counted out. You can count by 2s, you can count by 5s, you can count by 50. You just have to count by the same number for the bins. Okay, I'm gonna have you, now that you understand how to do histograms, do a little bit of work in Google Classroom to help you practice this.